Welcome everyone. In this video we are going to find the derivative of x raised to the power of x with respect to x. So the question that we have is, what is the dx of the function x raised to the power of x? So you might be tempted to use the power rule in this case. You might be tempted to say, okay, this is equal to x, we bring the exponent forward, times x raised to the power of x minus 1. And my friends, this is completely wrong. Please do not do this. I have a video about the power rule. You can find it from the cards right now. And I'm just going to briefly go over why we can't use the power rule here. Because we can't use the power rule because power rule is used when the power of x, the power of our variable, is a number. It should be a constant, okay? If we have x raised to the power of 23, for example, then we can use the power rule. But if we have something else, if we have a variable as the power of x, then the power rule does not apply. Alright then, cool, we learned a wrong way of doing it, but let's now learn the right way of doing it. I want to define y is equal to x raised to the power of x. So our question actually becomes, what is dy dx? Because we replaced x to the power of x by y. So we are interested in dy dx. Now I will use this equation and I am going to take the natural logarithm of both sides. So on the left we are going to have ln y, and on the right we are going to have ln x raised to the power of x. And it is one of the properties of logarithms that you can bring this exponent forward. So when we do that, we have x ln x. And then now I want to take the derivative of both sides with respect to x. I keep saying x all the time, but hey, we have x to the power of x. That is what we get if we ask a question like that. So we have d dx of both sides. And let me even put brackets here to emphasize it. This is cool. Now look at the left. On the left, we have something, some function in terms of y, and we're taking the derivative with respect to x. So this is a great place to use the chain rule. And using the chain rule, I will take the derivative of ln y with respect to y first of all, and then I'm going to take the derivative of y with respect to x. Okay, this is coming from the chain rule. Then this is going to be equal to, well, we have a product of two functions here, and we don't need the chain rule because we only have x in our functions. So how can we take the derivative of a product? Well, I have a video about it. You can find it from the cards right now. And if you know the formula, or if you watch my video, then you're going to have the derivative of the first one. What is the derivative of x with respect to x? It is 1 times the second one, which is ln x, plus the derivative of the first one. What is the derivative of ln x with respect to x? It is 1 over x, and then we have times the second one. So we get ln x plus 1 because x's here, they cancel. So this is great. And also if you look at the left, on the left we have the derivative of ln y with respect to y. It doesn't change, we only have x. Instead of y, we only have x. I mean, come on. I meant instead of x, we only have y. So we will use the same kind of reasoning to say this derivative is 1 over y. We just said the derivative of ln of x with respect to x is 1 over x. So if you replace x by y, the result doesn't change, it only transforms like this. And then we have dy dx is equal to ln x plus 1. Now if I solve for dy dx, because remember that is what we are trying to find, then I'm going to get dy dx is equal to ln x plus 1 times y. And now let's substitute for dy dx and y, because At the beginning, they weren't given to us. We defined them. And whenever we define a quantity in a problem, we should, at the end, we should convert it to the givens. Because if we make a definition that is not given in the problem, well, then we can't give it as our final answer. That would not be expected. That would not be expected and not accepted as well. So what is dy dx? We defined it to be dx raised to the power of x dx. So this is the derivative that we are looking for. And we are very close to find it. We have ln x plus 1. And what is y? We defined it as, it is right here, we defined it as x raised to the power of x. So we actually did it. We have a formula for finding the derivative of x raised to the power of x with respect to x. It turns out to be x raised to the power of x times the quantity ln x plus 1. Anyways, I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.